We'll invite our next guest to come close to the stage. Harald.
Well, welcome. Thank you very much for being here to listen to me today. And I'd like to talk to you about a world connected by light. So, going forward, imagine when light, the same light that we see every day, can connect you to the internet. Well, at pureLiFi, we see the opportunity for every light to connect every device and everyone, everywhere. That is LiFi. We've been talking a lot about the future applications that are being enabled in the coming years, in particular through 5G, through IoT, as we just saw. And going forward, looking at autonomous vehicles, automated intelligent homes, mixed reality, virtual reality, we know that all of these applications are relying on data and on connectivity. But how much data do we actually need? Well, Cisco shows us that we've been increasing the amount of data we consume on a daily basis at 60% every year. Exponentially, what that means is that in 5 years, as a society, we'll be transmitting 10 times more data than we are today. That's a staggering amount. And on top of that, there's going to be 20 billion connected devices by 2020. That's in 2 years. You know, there's other reports that say 30, that say 50 billion. What the number will be, we don't know, but we know that it's exploding. And a recent report from Nokia earlier this year predicted that actually in that same year, by 2020, 31% of data won't be met with existing radio infrastructures. That's 1 in 3 devices. This is what we call the spectrum crunch. And in order to be able to serve this growing demand for wireless data, to solve this spectrum crunch, we need a new technology. And this is LiFi. LiFi uses the visible light spectrum to communicate data. And the visible light spectrum itself has over 1,000 times more bandwidth than all of radio frequency put together. That means 1,000 times more bandwidth resources, more resources for all of us. And that's why it's key for future networks. But what is LiFi? Well, LiFi is as simple as if we look up at the ceiling and see the lights that we have in this hall, each one of those lights can connect us to the internet. It's a fully mobile, wireless communication system using the existing lighting infrastructure. And how does it work? Well, what we're actually doing is we're modulating each one of the lights separately. We're providing information signals to those lights, and then from those lights in the areas that they illuminate. Each light effectively functions as its own access point and serves the devices that are underneath it. But on top of that, when I network all of my lights together, I can create a wireless communication system, effectively a cellular communication system through my lighting infrastructure. And going forward, all of our devices are going to be able to connect seamlessly and move seamlessly throughout this illuminated and communicated area. So what are some of the key benefits of using the lights themselves? Well, first of all, as I mentioned before, light has over 1,000 times more bandwidth available than radio. For those of us who know mobile communications, we know that bandwidth scales, or speed scales directly with bandwidth. So that means theoretically I have 1,000 times more data rate available with light just off the bat. In fact, in the lab, we've already shown over 10 gigabit per second from a single light fixture. Now multiply that with all of the lights that we have here, or take it to your offices, to your homes. That's the potential that we have of speed with LiFi. But on top of that, look at how many lights we have in our various areas. There's just about 9 above just this small space. I can't count how many in the hall here, but certainly more than any number of Wi-Fi access points I have around me. The solution of simply adding more and more wireless access points doesn't work because they're going to continue to interfere with each other. But with the directionality of light, I can much more densely reuse my spectrum and thereby give more dedicated coverage to all of my users. So that also helps us in the data rate department and the bandwidth department. But there's also other benefits that light provides. First of all, the fact that light doesn't go through walls, the fact that it's containable, allows us to create secure wireless networks. If we had a LiFi system in this hall, no one from outside it would be able to detect it. We'd have a completely private network. On top of that, light doesn't receive interference or generate interference from the typical radio sources. So that means that, again, I can densely co-locate LiFi networks, but I also don't have to be worried about my cellular or Wi-Fi signals interfering with that system. It gives me a more reliable communication. The fact I have so many lights allows me to much more precisely locate my users, even if I add triangulation on top of that. And of course, doubling up on an infrastructure gives us the opportunity to create smarter lighting systems, smarter building systems, and more energy efficient ones as well. I mean, I've already mentioned how many lights there are around us. Imagine extending this hall to your offices, to your homes, to shopping malls, to street lights. There's over 40 billion light sockets in the world. And now imagine if each one of these could become a wireless access point. That's the potential that we have for this tech. It can be as local as to your desk, extend to your entire building, but all the way as large to every light in every city being a wireless access point. The additional capacity that we can provide over LiFi from all of these connections is really what we see as a solution to the spectrum crunch that's coming forward. But let's have a look at some of the more specific applications that we expect to be seeing within the next 5 years. In particular, looking at Industry 4.0, where I want to be able to manufacture something as a prototype at the same cost it's going to take me when I produce it in the millions. Speeding up prototyping, reducing the cost for small and medium enterprises to bring their technologies and inventions into the market. In the future, I'm not going to be driving to work, I'm going to be driven. Some of us like that more than others, but ultimately my car itself is going to be taking me to the places I need to go. And those autonomous vehicles are going to rely on connectivity. And finally, we've already seen the advent of the smart home, coming all the way from smart thermostats to censored environments. In the future, all of our devices are going to be interconnected. And again, that relies massively on wireless communication. In industrial and in manufacturing environments, this is a pretty typical scene. A worker is walking around either with a paper, maybe it's upgraded to a notebook nowadays, but they're moving to the various areas where the information and data from sensors, from machines, from processes are being stored, collected, and then walking all the way back to the central processing site to be able to then log that information and pass it on to the system. Well, this is really antiquated, it's slow, it's prone to human errors, all of it making it expensive and not competitive going forward. Actually, the head of innovation and digitalization at BMW tells us that in the manufacturing process, every single second counts. And so what the manufacturers of the future want is not to run around with a clipboard, but rather to have more data from more sensors available in a quick and reliable manner in real time. And that needs communication. Again, we spoke about driving before. This is one of the areas I want to highlight. Actually, a lot of people probably would like to see autonomous vehicles on the road already. already are tired of driving to their offices and to their homes back and forth every day. But we don't have that yet because we're still looking for autonomous vehicles to take the next step. We're looking for the reaction times to be faster, to have safer passage. We're looking for more reliable information to be delivered to the cars at any given point in time. And of course, I want all of this data to be secure. Nobody wants to be carjacked over software. And then finally, in the home, already actually almost everything is wirelessly connected. And we're suffering. I know I am at home. I suffer from slow speeds due to the interference from neighbors, dead spots in areas where I might have a sensor located, creepy neighbors who can see all of my data, and the fact that I have to share the bandwidth with all the people in my home. As we add further and further smart things, we're only creating our own spectrum crunch in these environments. And so, again, a new solution is needed. So how does LiFi fit into all of these areas? Over the next 15 to 20 minutes, I'd like to take you a bit deeper into these environments that we want to enable and where LiFi will play a big role. So based on some of the work that we've done with BMW, we know that their new connected network of sensors has increased their Munich facility's ability to produce cars from 250 all the way to 600 a day. That's a massive improvement just from being able to sensor enable that environment. They're able to monitor a wide variety of facets of the factory. They're able to automate a lot of the processes that before would have been done in a manual fashion. And they can also predict when a line might go down, maintain it in advance to ensure that those seconds aren't lost. But this is just the beginning. As we add more and more sensors and more devices, we're going to need wireless communications. And that's what this is going to result in. A dark, self-interfering haze of radio frequency communications. The more sensors I add, the more devices I enable, the more machines that I want to connect, the more interference each one of these will be generating, and the more access points I try to put in, the more they'll be generating as well. And that doesn't even account for the noise that's coming from the manufacturing floor that'll be interfering with those. But if I go to light, I can clear up this haze. Each light can deliver high bandwidth in a dense fashion to the sensors and machines and devices that are directly below it. On top of that, each one of these sensors now becomes mobile. It doesn't need to be placed in the same area all the time, and all that cabling infrastructure that I had before doesn't need maintenance. If I look at some of the robots that are on the manufacturing line, wirelessly enabling them through LiFi not only, again, reduces my CapEx and the OpEx for that robot, for that machine, it makes it mobile. It means I can re-optimize my factory as I move forward. And on top of that, outside of the factory itself, there's still a huge amount of interference that's being generated. Actually, one of the partners that we work with isn't able to have Wi-Fi in the offices next to their factory because they actually drop the production line every once someone accesses the internet. There, we've taken LiFi to enable the offices around, to enable the areas around, to provide greater speeds, higher reliability, and low latency in those environments as well, which is, of course, key for those production processes. Based on all of this, we've seen that we know that LiFi is key for enabling Industry 4.0 and future manufacturing. Now let's pivot again to the autonomous vehicle. This is a data monster. If we look at some of the predictions that are up here, in fact, Intel predicts that an autonomous vehicle will be transmitting and receiving over 4,000 gigabytes, that's 4 terabytes of data every single day. Now imagine in a city like Bucharest, where there's over 1 million cars, and then think about the struggles we already have with regards to bandwidth that we get from those mobile networks. Add 1 million cars times 4 terabytes every single day, And we know there's no way that the existing infrastructures are going to be able to support that massive data demand. And there again, we need another solution. Fortunately, in the driving environment, we have tons and tons of lights available already. We can start with our basic street lighting infrastructure. In particular, within the cities, street lighting is dense. It's designed to provide seamless illumination where we're driving. And so I can enable my cars, my vehicles, my trucks, to connect to each individual streetlight as it passes to transmit and receive location-relevant data. Not only that, I can also understand the information that I have for the trajectory that I'm on. And I can potentially optimize that trajectory based on the overall system information. But if I take it one step further and we look at the vehicles themselves, almost all vehicles these days have LED headlights and taillights. So I can use those lights to effectively create a mesh network over LiFi between all the vehicles that are on the road. And because of the uninterfered nature of light, because of the fact that LiFi is high bandwidth and low latency, it means that I have reliable communications between the cars and to the infrastructure, but also I have fast communications, increasing the safety of all the passengers. And if we look at this from a citywide perspective, we see a massive amount of opportunities. Now, I'm not saying that radio doesn't have a part to play in this infrastructure, helping with the citywide coordination of these autonomous vehicle flows. But with LiFi, with the street lights, with the car-to-car communications, I can use the information I have on the location and the trajectory of each of my cars to optimize traffic flow throughout a city on a minute-by-minute basis, practically in real time. On top of that, of course, I mentioned before that with the fast reaction times, if a car 5 cars in front of me is braking all of a sudden, the fast communications between them means that I can brake immediately as well, preventing accidents. And finally, again, looking at historical traffic flows based on location, much more dense location. I can do predictive maintenance on my various infrastructures around the city. I can fix the pothole that's coming before it even happens, and thereby further optimize the transportation throughout my city. With LiFi and autonomous vehicles, we can further power the economies of our cities and our countries. But where is it that we as a society or as users transmit and receive, communicate the most amount of data? It's actually in our homes. By 2020, we predict that over 50% of our data will be transmitted and received in home environments. And so this puts a lot of pressure on those systems. Nowadays, most people have Wi-Fi in their homes, I would imagine. And they suffer from quite a few aspects. I know I have. I've suffered from slow speeds, from interfering neighbors. I've suffered from dead spots in areas where I may have wanted to locate a sensor or IoT-connected device. And the fact that I only have this one access point is really where this challenge comes from. Now, there are mesh network, mesh Wi-Fi protocols coming on board now that can solve this issue. But then this compounds it to another step. Within my own domicile, I might be able to improve my coverage. But if I'm living in an apartment building, or if I take it to my office space in a multi-tenant building, all of a sudden, all those Wi-Fi access points and those mesh Wi-Fi systems are again interfering with one another. I'm sure that when we walk down the main commerce street here in Bucharest, you see about 50 or 60 different wireless access points. And that's only because your phone can only connect to that many at any point in time. Actually, the fact that I have such a wide, uncoordinated deployment of Wi-Fi in such dense environments means that any coverage benefits I have from mesh systems are eroded. And actually, the amount of bandwidth and the data rate that I can provide over Wi-Fi is also negated. But if I again move to LiFi within my home, I have a number of advantages. First of all, each light can provide me high density coverage and high bandwidth coverage. I can enable it in those areas that I want to, just by simply plugging in the light. And I'm not interfering the neighbors around me. In fact, each LiFi home system is private to its own user. Thereby, we can more reliably guarantee a higher quality of service across the range of IoT, mobile connected devices, and of course, autonomous systems. If we focus on actually one of the applications I mentioned before, which I believe is going to play a huge role in the home going forward, is virtual reality. We've all seen some of the initial prototypes, some of the initial product concepts around VR going forward, but I'm sure we'd like it to come faster. But let's look at the requirements that we actually have of modern VR systems. For a relatively low quality VR headset that's bulky, that delivers me the minimum viable product, I'm already looking at 210 megabit per second needing to be delivered. Now, most modern Wi-Fi systems should be able to do that, I would agree. But let's step it up to a medium quality signal. Well, that already moves my needle over the 1 gigabit per second line, and now I'm already in the range that I need a cable to be able to communicate with that device. But if we really think about what we want from VR, it's that complete ultra-high def immersive experience with ultra-high quality. And there, from what we can see from the current predictions, is that we're looking at over 14 gigabit per second per headset and per device. This is a huge growth that we're going to need to stem. Now, some of you might be thinking, well, with radio technologies as they develop, I might actually be able to reach such speeds. And I don't disagree. But then, what happens when I have a buddy with me? Or I have two? Now, all of a sudden, I have to deliver not 14, but 28, but 42 gigabit per second in a very, very small area. And as we all know, Wi-Fi doesn't deal well in small areas. With light, however, I can deliver very dedicated coverage to each individual device at high bandwidths and at the low latencies that VR needs. So here again, LiFi can play a major impact in the adoption of this technology. And then what happens if we want more? To go even further, to go to the 100 gigabit per second. We're going to need LiFi in collaboration with those existing infrastructures to be able to serve these applications. I'm sure most of you have one of these in your home as well. I mean, I do, and I actually find it very useful. And I'm always thinking of new ways that I can use it to enable new features. But I do have one central challenge. She's just not responsive enough. You know, if I say, OK, Google, very often I get this. And the reason for that is that nowadays I have a centralized infrastructure whereby actually my data center and cloud platforms are located thousands of kilometers away, increasing the latency between my OK Google and the answer that I'm looking for. But what if we could now look at a new infrastructure? So look at a typical office building, and we know we've already been speaking about the fact that with LiFi, I can provide connectivity, and I can provide it in a secure manner in this space. But now that I've connected my lights, that means that I have a new accessible infrastructure by nature. So imagine if I now added memory to each one of my light bulbs. They're already networked. They're accessible from the network and from my devices, meaning that I've now created a local cloud infrastructure just on my lighting system that can host my personal data, the data from my sensors, my things. let me take it one step further. And now I add computational capacity to every light bulb. Not only do I have storage there, each light bulb is now a server, and when they're networked, I've created a local data center. That means that the various data that I have can be worked on that local data center. Excuse me. There we go. It also means that the analytics that I want to perform on my smart home system, on my IoT network at home, can be performed locally. And the autonomous decisions by the smart AI that I have in future home systems can also be done locally. It doesn't need to go back to the data center anymore, meaning I can improve the latency of it, and I can improve its privacy, and overall I can improve the edge capacity and the edge communications of the network as a whole. So I can now actually host my home assistant on that private network, meaning that all that calculation can be done right there and then. So with LiFi, because we're connecting a new but existing infrastructure, not only have I increased my communications bandwidth, but I've also created or set up a new infrastructure for our information and intelligence technologies. If you still don't believe me, let me remind you of a few things that people didn't believe in, but are commonplace today. Some of us in this room may not remember these, but I think most of us do. During when we had a 1.4 megabyte floppy disk that we could proudly carry our Word documents on from desktop to desktop. Well, that evolved into the CD, which had 700 megabytes of music or maybe one movie on it. And that transformed into the thumb drives and sticks that we have nowadays that host gigabytes of movies, of data that we can carry around with us. At each one of these steps, people thought, well, this is actually enough. I don't need more data than this. And at each step, we were proven wrong. Nowadays, everyone has one of these in their pocket with up to 256 gigabyte of storage. And this is only increasing further. There was a point, actually, back in the day when the mobile phone companies didn't believe that having a camera in your phone was a good idea, because everyone had one of these. Everyone had spent a few $100s on such a camera, and they said, well, they'll of course be using that device. Why would I need to put it in my phone? Well, nowadays, 1 billion people have camera phones, and they're taking over 1.2 trillion photos every single year. How wrong were they? And of course, with these 1.2 trillion photos, everyone wants to share them, whether on Facebook, on Instagram, on Snapchat. In fact, it's predicted that each and every person is producing over 1.5 gigabyte of data every single day that we're looking to share. Again, this is a massive amount of connectivity. And so seeing these trends, you can't tell me that we're not going to need new solutions, even in the very near future, on top of our existing radio frequency infrastructures. In fact, there's an avalanche of data coming towards us. We spoke about the 1.5 gig of traffic every day. We spoke about autonomous vehicles needing 4 terabyte of data every day. Smart factories looking at 1 petabyte of data a day, and cloud video providers that is well beyond any of those. We're going to need more spectrum and a new infrastructure to be able to sustain all of this on the same network. And we have that with LiFi. With LiFi, we have high bandwidth and high-speed connectivity in a secure way, and we can enable the new infrastructure with memory, with computational capacity, and the intelligence, all on the same infrastructure. And this is how we're going to realize the vision of every light connecting every device and everyone, everywhere. Thank you.
Thank you, Harald. Brilliant questions. Over here.
I thought you would go.
Shall I use this? Thank you. Very interesting. I just wonder if you can state which are or discuss a little bit which are the challenges that you see in order to do what you want to do. I mean, I can see more immediate in indoor environment, but when we go in a city environment, it's become a bit more complicated. Just a few words on your consideration on the challenges you have ahead.
Sure. So, I mean, I think it's a very good point you made, first of all, about indoor being the first area. And we do actually look at over 90% of communication coming from indoor areas, which is why we target that initially. I think some of the challenges that we have that aren't necessarily unique to our technology is the integration into devices, is to the miniaturization of the product, and including that in the smartphones and tablets and laptops and IoT devices we have going forward. I think the other area is on the infrastructure side, of course, and there outdoors is much more challenging. But one of the things that we are looking at is how, together with 5G, we can either use LiFi in conjunction with that on the access side, or potentially use part of the 5G infrastructure as the back end to the streetlights, for example. But there's also a number of areas where we might not need the infrastructure. So looking at device-to-device communications or digital signage that gives me information that is relevant for that particular day. So I think the infrastructure rollout outdoors certainly is one of the key challenges we see going forward. But we're looking at working with partners in order to do that.
Okay, some other questions? Over here.
Hi, again, thank you for the presentation. I will build a little bit on what you asked regarding the challenges of LiFi, and I'm wondering a little bit if you have if you have maybe solutions for situations where, how should I put this? Wi-Fi goes through buildings, goes through objects, goes through floors, etc. Light doesn't.
Yeah.
And when you're talking about an indoor scenario, maybe I want to connect my telephone using LiFi, but then a book falls on top of it, and then the light is blocked. So that's one point. And the other one, when you're talking about outside environment, what do you do when there's fog or other light obstruction environment? I don't know, if weather or anything else. So do you have any solution regarding to that?
Well, we do. I would answer that question in two ways. So, I think when just linking over LiFi, instead of a book falling on the phone, I'll give you a better example, is when it's in my pocket. Now, I'm not expecting to get a LiFi call now. But as soon as I take the phone out of my pocket, as soon as I start surfing, as soon as I start using it, I'm naturally within the coverage area of a light. So that's how, I guess, I would remove the book. But the main point is that we see LiFi as being a massive part of future networks, but not by itself. Actually, you look at Wi-Fi hasn't replaced 2G, 3G, 4G. Actually, none of them have replaced each other even. So those are working in conjunction with each other. Wi-Fi more focused indoors and cellular actually more general. And we see LiFi working alongside those as well. So when it's in my pocket or when it's under a book, then I'm expecting Wi-Fi or 4G or 5G to pick up that call. But as soon as I actively take it out, start doing the FaceTime call, for example, or downloading the video or watching the 4K stream, typically the phone is in an open environment again. And there also we deal with blockages from a networked fashion. So I might be blocked from that light, but still have connection to that light. So there's a variety of ways that we address it. But part of what we're doing as well is standardizing the technology in 802.11. So it automatically becomes interoperable with Wi-Fi and cellular techniques as well. So it's about building on the existing platform, not necessarily replacing it. But what I tried to highlight here, was just a few areas where we're already seeing customers coming to us that they've reached barriers with existing radio technologies. And so LiFi will add to those there, but be critical in enabling them.
Okay, so what you're saying is that LiFi is complementary to what we already have.
Yes, and additive
as a communication technology.
And additive to it, yeah.
Okay, thank you.
Over here, there's another question. Just.
So I missed the part at the beginning. I wanted to ask you, is LiFi only possible through LED lights and not incandescent light?
Yeah, it currently works off LED lights, yes.
Okay. Do you think that this will help to spread the access to internet in the communities that don't have it through radio systems?
Well, I think that as with most new technology, it gets rolled out in the areas where the need is highest, where the demand is the highest. Where we see light being particularly useful in digital divide areas, for example, or communities where there's currently no radio, is actually looking at backhaul systems that rely on LiFi as well, on lighting in the back end. The goal for us longer term is to get the technology to the cost point that it is as simple as switching in a new light bulb that's LED enabled, and especially in areas where we don't have LED lights already, we can then do that as part of that upgrade. So I think that while the initial rollouts will be in the high demand areas, certainly it'll catch up from the back end as well. And there may be places where radio is not needed, actually, and we can go straight to LiFi.
Over there, there's another question.
Do you have a time frame? I mean, realistically speaking and optimistically speaking, when do you see those scenarios that you presented happening? So how far advanced is this technology? I mean, the project.
Yeah. So I think it depends on the scenario. In the industrial automation side, we already have a wide range of projects that are ongoing to enable the wireless factory over LiFi, because Wi-Fi simply doesn't work in some of those environments. So that's something that's already ongoing right now. I think if we look at the smart home and autonomous vehicles in particular, standardization of the technology will be needed. Now, the standardization time frame for us is for it to be ratified in the 2020-2021 time frame, so 2 to 3 years away. Of course, there's product development that needs to happen alongside that as well. So I guess to answer your question, optimistically speaking, 3 years, potentially actually within the next 5 years, however, we do want to have systems like this online and be able to, for you to be able to retrofit your home with LiFi.
Okay.
We'll talk later. I'll give you my card.
Okay, so there's one more question here.
What about on business models? Now, I can imagine private network as an idea, more public network maybe a bit more complicated. I can imagine the utility maybe like the idea, the municipality like the idea. How do you imagine the business models you will have? I guess you need to have different business model in different contexts.
Yes, yeah, no, for sure. I mean, I think in terms of monetizing LiFi from a municipality perspective in the same way that Wi-Fi was initially monetized, I don't think is feasible. I mean, I know I actually recently had the experience where I went into a hotel and they wanted me to pay for Wi-Fi, and I told them it was 2018, please come to the future. But so I don't think that just simply monetizing it directly is the way that is a viable business model, except in very, very dense environments like conference centers, for example. But in terms of where we see the business models in the industrial space, for example, is cost savings around CapEx and OpEx from reduction of downtime, so being able to get that guarantee all those seconds that the head of innovation at BMW is looking for. In the smart home, it focuses probably on the ability for the variety of sensors to be tied to locations. So not only can I improve the latency, as I was telling before, but actually I can get more location-relevant data on my home, allowing actually the AI systems to have better information and more autonomy of that environment. I think, for pureLiFi as a company, we are a B2B place, so we're not taking it directly to the end consumer. It'll be through the various devices. But even being able to enable VR wirelessly with multiple people is a new concept that I think that people will be paying for in the very near future. So I've probably not been able to answer your question in dollar terms, but of course we need to work on that as well.
I'm extremely curious at a very specific level because we are familiar with Wi-Fi, with routers and everything. What exactly do you need to implement in a, I don't know, in a bulb or something to have this going?
That's a very good question, and it's an easy answer. We produce pretty much the same type of devices. So you have the same kind of router or access point in each and every light, and then the technology will be in a chipset that is integrated into your devices. Now, of course, we're not there yet. pureLiFi is still at the dongle stage, as Wi-Fi was a number of years ago, but that's definitely where the technology stream is heading. So the ideal case is that actually, apart from the areas where in industry, for example, it's very specifically around LiFi, you'll be using cellular, Wi-Fi, and LiFi all at the same time without even knowing it, and it'll be a seamless experience.
But what should the industry do, let's say, after you have a standardized technology? So they have to implement these kind of things in what they produce, that being, I don't know, bulbs or anything else?
Yeah, actually, one of the interesting areas is for lighting companies because it opens up an entirely new business model for them. So they can now enter the communications space. So we already work with lighting companies to integrate our electronics into their lights. Going forward, ideally those are semiconductor components from a variety of suppliers that can be integrated at low cost into the LED lights. And then we need to work with the mobile device manufacturers and sensor providers and the VR providers in order to get it incorporated there. I think, again, standardization plays a key role in that, and you have effectively the same ecosystem as Wi-Fi, looking at LiFi as the next stage of that evolution. But yeah, it will be integrated going forward.
Questions? Any more questions? Okay, over here. I think we'll take one or...
Sorry, I wasn't present from the beginning of your presentation, but sounds interesting to me. Tell us more about similarity with fiber optics technology and the limitation of your technology. So, do you have concepts like DVDM, like in fiber optics or something like that? Do you do you consider technologies like in fiber optics, and are you able to offer new beginnings of this technology in your environment?
It's a very good question. So actually, in fiber optics, typically you're using laser-based sources for much higher bandwidths. At the moment, we're looking at using LEDs themselves, so it's not exactly the same coherent modulation, but rather we effectively modulate the intensity of the light at millions of times a second. So the light's flickering in a pulsed fashion, but we use, if you're familiar with OFDM, we use that to superimpose that onto the lighting signal itself. Can we go to laser-based solutions that reuse some of that technology going forward? We are already looking at intensity modulation of laser sources for much higher data rates. Whether we can go to coherent detection is still on the research roadmap, let's put it that way. But certainly there are similarities between fiber and light, but those are more in the research area at the moment, not in the practical implementation.
Thank you. Thank you very much, Harald.
Thank you.